everyone, this is Craig Trumpy with ATech and AssetScan. Today I'm going to talk about extending reliability with IIoT with a video on a case study on a makeup air fan showing a bearing fault and shaft damage. So let's get started again from AssetScan.com. You can log in with username and password credentials. You can go to your portal, in this case our ATech Metals plant in Iowa, and we can pull up our assets that we're monitoring there. In this case we have three assets. The asset of interest is this middle one, which is our makeup air fan on the top of our building. Moving to the right hand side of the screen to pull up our trend data, we can click on the trend icon for overall vibration and fault peak detection, and we see a 30-day trend of overall vibration, again 0 to 1000 hertz in velocity or inches per second, and the ultrasonic trend line in green, which is reading 1000 to 25,000 hertz and is in the units of Gs. If I want to move back and see further in time, I can zoom back to 90 days. And I can see upon initial deployment of this AssetScan, we saw the green line above 6 Gs as well, which triggered a prescriptive task to field inspect and lubricate this bearing. Upon field inspection, he noticed there was a gap in between the inner race of the bearing and the shaft, indicating the bearing was not supporting the shaft, and the shaft had been spinning on that inner race and sliding and essentially wearing that shaft down. After field inspection, it was determined that a bearing needed to be replaced. They decided that rather than changing out that shaft and fan rotor, they would build a foundation for a separate bearing location and install a split bearing. And so 54 days later, that bearing was replaced, and you can see the fan bearing is running good at 2 to 3 Gs. So I'll just show you a couple pictures of the work that the guys did. Here is a picture of them cutting out that existing bearing and the condition of the bearing and grease. Here is a picture of the shaft worn down by sliding in that existing seized bearing. Here is a picture of the support that was built for the split bearing, and the split bearing partially installed. Here is the split bearing nearly installed, just waiting for the top half of the bearing housing to be put on. And here is a completed look at the new split bearing and new location on the shaft with the grease fitting and external grease zerks hooked up so we can grease this bearing moving forward. A couple other facts about this makeup air fan, why we selected to monitor it. We had a sister makeup air fan that had failed a year or two back, that the bearing failed and the fan rotor did contact the shroud and did do quite a bit of damage, and so this save is determined to be a $30,000 to $40,000 savings. The past practices, we would have ran this blind of any vibration or ultrasonic, and we would have run it to failure, where we would have let the rotor meet up with the shroud and had collateral damage. So to conclude this case, again, what we demonstrated is the ultrasonic versus the vibration monitoring. We demonstrated the artificial intelligence model of 6, 12, and 18 Gs on our ultrasonic that leads to a very prescriptive task, and it gives them enough time to do the planned work, planning and scheduling to do work of this order of magnitude. Lastly, it demonstrates how to deploy an Internet of Things sensor with existing cellular, so you can work from rooftop assets and move that data right into your desktop and or smartphone. If you have any questions, feel free to reach out to us at AssetScan.com. Thanks for joining us today.